Welcome to White Memorial, everyone. My name is Jamie Fisher. I'm a research director here. I'm a biologist, ecologist. I work primarily with terrestrial ecosystems, that's stuff on land, and I've decided to take the plunge, literally and figuratively, into the depths of lake management. So what Bantam Lake has accomplished over the last 10 years has actually been quite impressive, especially for a grassroots organization that is completely made up of volunteers, and the collaboration that we've had with White Memorial. And in terms of the weed management program, we've had some successes over the past 10 or 11, 12 years. One of which was we've been able to eradicate water chestnut. This was, we only had about like 2 plants, a total of 2 plants in 2006, I believe, and it was hand pulled, and we can say that it's been safely eradicated from the lake. And that's really the best management strategy we can use when it comes to invasive aquatic plants, and that is get to them as early as possible, so that when they start to, before they even begin to multiply. And you can see on the right that these are the seeds or the fruits of this invasive plant. They're large, big thorns all around them. It would make going swimming in the lake kind of a hazardous environment. I had some good success with controlling fanwort. This is a dominant plant that was in the Bantam River from as far north as Goshen area, all the way through the river ecosystem, down towards the lake. It did enter the lake at some point. We put up a weed barrier system at the mouth of the inlet, and that prevented it from spreading throughout the lake for the most part. Then we went to a suction harvest methodology, which was essentially a cutting-edge technique that was used primarily as an example here at Bantam Lake. This was using a great big sort of suction vacuum that would go plant by plant with snorkelers out at the lake and suck up the plants and then put them into and then take them out of the lake. We subsequently then went to herbicide treatments throughout the river, and we've had very good success at controlling the fanwort in the river. I believe there was about 2 or 3 seasons ago where we applied the herbicide, and we haven't had to go back in for quite some ever since, and it still seems to be under control. So it's under control. We've had a success there. The next species is Eurasian water milfoil. Again, under control, and the good news, for the first time since the aquatic plant management program has been going on in Bantam Lake, for the very first time, our surveys have not found the plant in the lake. It's 0. Wow. It does not mean that the plant is gone. It doesn't mean that it's eradicated. It's, again, we're surveying, we're doing surveillance work, but for the first time we haven't found it, and that's really good success. We have been making good strides in controlling the plants to the point where we're treating less of the lake in terms of the total acreage over the past 10 years, and so we're getting much more strategic and targeted with our approach. So we're having good success. We're winning the war, but we still must wage the battles every year. That's the key to this battle that we're dealing with. But also, new things are always on the edge of being introduced to Bantam Lake, whether it's by boats or by accidental introductions or whatever. These things are still on the edge of the lake, so to speak, and they're ready to enter at any one time. So we have to stay vigilant. We can't get lackadaisical at this with these plants. So we must maintain some effort towards managing invasive plants annually. The new challenges. Well, they're not new, that's for sure. They've been around on the planet for about 3.5 billion years, but the new challenges for the lake that we're facing, and I think we're all starting to see this and recognize it, is the fact that we are experiencing annual cyanobacteria blooms. They are also referred to as blue-green algae, commonly called blue-green algae. You'll also see the term HABs, which are harmful algal blooms. You'll see that on the internet. But these are cyanobacteria. They're simple organisms for the most part. They've been around on the planet for a very long time. They are beneficial to us because they do produce oxygen. They do fix nitrogen. And so they're the things that sort of came onto this planet and created the atmosphere that we're breathing today. So there are benefits to these things. Obviously, though, when we see, and these are from the lake itself from last year, when we see conditions like this, where there's a bloom forming, there's an imbalance. There's something not quite right. And I think we'd all agree with that, that it's not something we need to encourage. One of the things that makes them sort of bloom like this is that they're able to regulate their own buoyancy in the water column. So this is a paper from 2015. It was, granted this is an experiment in the lab using test tubes, and we have to be careful extrapolating that to the lake system whenever you take it from a test tube. But basically what this was demonstrating is that it doesn't take very long for the cyanobacteria to sort of congregate and move themselves up to the surface of the water as through their buoyancy, and this is what the paper was describing, is trying to understand that buoyancy effect, creating a scum. And so once that scum is at the top of the lake, a nice breeze can push that scum up against the shoreline and can cause them to be even denser. The reason why we're most concerned about this is that cyanobacteria naturally emit toxins. These toxins are used by the cyanobacteria to avoid predation. So they don't want to be eaten, so they emit toxins. They've been around a long time, so they've come up with some good strategies on how to avoid this. But when you get these high concentrations of cyanobacteria, we can then see toxins in high concentrations in the water right along those shorelines. And that's why we're getting very concerned about cyanobacteria blooms. Now, this is not just something that's happening at Bantam Lake. This is happening around the world in lots of different lakes. It's primarily caused by eutrophication, or the fact that nutrients are entering into the lake ecosystem. So I've got kind of a complex figure up here, and I'm going to break this down into pieces, but we've got to start to look at this question. So a lot of people want to say, well, what's causing this problem? Well, first and foremost, the easy answer is lots of things are causing this problem. Lots of things are contributing to the problem, and we're going to break that down. But the main thing that these organisms must have to multiply rapidly is food. And their food is nutrients. It's phosphorus. It's nitrogen. For the most part, that's what they really need. But they also need sunlight. So they're photosynthetic. They produce their own energy by processing this food, the basic building blocks. So we have to address these factors. So I've taken that first image, and I've broken it down. So now I've broken it down into 3 different pieces across the top, and I'll just explain each one briefly. So the first thing we try to do is we try to reduce nutrient inputs. Nutrients are coming from the landscape around the lake and the watershed. So our land use decisions have a direct impact on how those nutrients flow into the water. They come from the atmosphere in the form of rain, but when we add pollution to the atmosphere, whether it's coming from our cars or our factories or whatnot, that nitrogen primarily is coming out into the rain and falling into the lake and into the watershed. And also, nutrients can be coming from the land itself, coming through the soil, through the seeping of the water through the soil. And that's really important, especially if we have deteriorating septic systems around the lake. That can carry nutrients and push them into the lake itself, but through the ground. So we have to be very careful about the age of our septic systems, the construction of them, the maintenance of them. We have to stay diligent, especially right around the lake and around the watershed, throughout the entire watershed, really. The next thing we have to start looking at is we have to look at the flow rates of the water coming into the lake. So we have to know how much water is coming in, how much water is coming out, how is that flow occurring, when does it happen, seasonally, so forth. So we have to look at the flushing out of the lake itself. The next thing we need to look at is how much mixing is occurring in the lake. And this is not like from north to south, this is from the top to the bottom, that kind of mixing. So we look from the stratification of the water, whether that's caused by thermal gradients in the water or by the wind shear going across the lake surface. There's a lot to that. As well as, and we all can see this, we saw this just in the last year. We're seeing some fluctuations in our precipitation. We see that we've gone through a drought recently. We're also going through a fairly wet time frame right now, and this past spring is pretty wet. So that kind of stuff is also going to have an influence on the lake. Now if we go to the bottom, That's where they break those down. So now breaking those down, we have to look at the sediment of the lake sediment, and there are methods that we can use to control that kind of nutrient cycling from the lake sediment. So the lake is obviously already has a lot of nutrients within it, and so the question is, how do we control that flow of energy and that flow of nutrients between the cyanobacteria and the sediment? We can do that by either capturing the energy or stabilizing it by putting certain materials into the water and onto the sediment that captures it or locks it up, basically binds it up, or we can dredge it out. We can dredge out that sediment. We can also try to use naturally occurring biological control agents. Now this is difficult in large lakes. I'll be forthright with you. In small ponds and smaller lakes, this is a possibility. But in large lakes, this is really quite challenging. But it's the idea that maybe we have to start looking at what is the predator population, what is the consumers of these cyanobacteria, what are some of the things that are, and how does that carry through to the food chain itself? Excuse me. By and large, the only method we have right now that we are allowed to use to control cyanobacteria is the use of copper sulfate. Copper sulfate is a pretty toxic substance. It's been used on the lake for many years in the past, but without really due diligence. We're now thinking about possibly doing it if we start to experience blooms. There are side effects to this, though. There are a lot of implications, actually. First thing is, copper sulfate is toxic to a lot of organisms in the lake. Snails, mussels, these are important food, basic building blocks to a lot of basic food reserves for a lot of fish and birds. So we have to be careful of using copper sulfate in proximity to those things. Second thing is, copper sulfate is a lysing agent. It breaks the whole structure of the cyanobacteria body apart. It just breaks them up. The implication of that is, if we use it, we might release more toxins into the water. And so we have to let those toxins dissipate after we use the copper sulfate. Now, George Knockline has had quite a bit of experience with applying this product, and he's seen it used, and so we have a pretty good advisor and consultant overseeing us. But again, and we also received the permits from the state of Connecticut. And so from Connecticut DEP, and also the health department is aware of our actions. So they're aware of what we may do. It's a bureaucratic process, but it's one that we have a lot of oversight, and we're going to be trying to do it very carefully and judiciously. But it's right now the only method we currently have on an annual basis for controlling cyanobacteria. 2016 was a pretty tough year for the lake. As a result, because of the cyanobacteria and because of our weeds, Connecticut DEP advised the EPA that Bantam Lake is now classified as an impaired lake under the U.S. Clean Water Act. That classification is a double-edged sword. So on one hand, it says that we are fully recognized that we have some problems in the lake, we have some issues that we're trying to deal with. On the other hand, by having that classification, we now make the EPA and other federal agencies aware of the fact that we need some help from them as well. And so that's where we're going to have to start lining up our process of thinking towards coming up with a way of saying, how do we make this impaired lake an unimpaired lake? How do we get to that process? And it's an extensive process. There's at least 9 big points to a plan that we've got to come up with. We've got to design this thing, and we've got to implement it over the next several years, if not decades, to demonstrate that we're ready and willing to take this on. This map shows you from 2010 the number of impaired water bodies already considered in the state of Connecticut. So we're not alone on this. And there's a few lakes, and there's a few ponds, and there's a lot of rivers already recognized as impaired water bodies and water courses in Connecticut, and a lot of our shoreline in Connecticut on the Long Island Sound is considered impaired. So we're just part of this sort of domino theory of impairment that's going on across the state. However, we are recognized as being a very special place, and that's the key. We're considered a natural history, natural treasure for the state. And so Connecticut DEP has recognized that the Bantam Lake watershed is a selected water for action, and they're going to put us into the restoration category of this plan that they have. So we are under the restoration part. So they've got us as one of their priorities in the state. So that's the good thing. We're on their radar, and they're going to help us out to the best of their abilities. We have to be willing and able to help ourselves first. That's the key, and that's the kind of thing that has to happen when we send the sort of the message to the EPA and the federal government, is that we're willing to help ourselves. And by doing so, they'll then come and help us out as well, either through money or through advisement or technical service. That's the part where they can play. But we've got to be the ones out there doing the work first. And we're already starting that, as you can see with the invasive plants. Now, up to this point, the thing that impresses me as a scientist is the value of data. And I am amazed, I am absolutely astonished how much data we have associated with Bantam Lake. And it's been going on for at least 40 years. 40 years of data that we can, trust me, I get excited by little things like this. You think the numbers are good, let me tell you. So, but let's just look at that, look at the history of the data itself. So we've got this 40 years worth of data in here, and it continues. But we have, most of it's been looking at nutrient sampling within the water column, also in the sediment, again looking at eutrophication as the way the nutrients are entering the lake. And so we have a pretty good idea what's going on, but we still have a lot more data that needs to be collected, and a lot more gaps in that data. Then we put a lot of effort, for the last several decades, we put a lot of effort into aquatic plants and trying to understand the aquatic plant community, how to manage the invasive plants. And we have had successes. So great, data means something, and we can actually make some good decisions. Now the challenge is cyanobacteria, looking at the phytoplankton and the zooplankton in that water column, and trying to figure that community out, and trying to figure out what's causing some of the factors that we're seeing out there. What are the forces? Where the future goes from this point forward is at critical junctures. So as you can see, Northeast Aquatic Research has played an important, really critical role in the last 2 decades. This is George Nachman. He's our principal investigator for Northeast Aquatic Research. And so he's been guiding us through this process. We've been getting on board with monitoring the cyanobacteria a little bit further with advising from a project that the EPA is providing. You can see that online, the images that we're collecting. And we're starting to go around the lake sampling stormwater. So the crazy person walking around the lake wearing a blaze orange vest and a raincoat when it's raining, that's me. It's my technician. It's my volunteers. And this is when we have to do this sampling. So when it's raining or the snow is thawing or whatever is happening, snow is melting, we're running around the lake trying to grab samples. But we've identified so far, 62 points around the lake where we can regularly sample stormwater in a rapid succession. And we're looking at the flow of nutrients, phosphorus and nitrogen for the most part, and we're collecting a little bottle of water, labeling it, taking a GPS unit, and we freeze it and send it for analysis. So that's the process. But 62 points have been identified so far, and there's a lot of places around the lake that are probably going to be relatively ephemeral, right? You're going to get the way water flows off the landscape is going to be very different if you have a half-inch rainstorm versus a 3-inch rainstorm. So sometimes we may be going to those points that are regularly scheduled for sampling, but other times we may just find a place where, geez, the water's just sheeting right off this parking lot. Let's grab a sample, and we do. So that kind of data is going to be collected over the next several years, and we're going to need some help with that over time. But that's where the future's going, and we're building this, folks. We are building this like mad. The other thing is that White Memorial is starting to look at, I'm starting to look at evaluating the feasibility of having a volunteer corps of folks going out onto the lake regularly, looking at some basic metrics. That's lowering like a metal disc down into the water, the Secchi disc, and seeing what the turbidity is like at various places throughout the lake, getting some water samples, maybe doing some sampling and collecting some more data. We're pretty good around here with collecting data from a volunteer perspective, and I'd like to start encouraging people to think about what you can do around the lake. Whether you're landowners or whether you are on the lake itself, you might be able to help us out. So please contact me if you're interested in helping. We're at the very initial stages of organizing our thoughts about this, but we've got to get more data and more robust data so we can start to fill in some of the gaps, because it's a very dynamic out there. So with that, I'd like to recognize our partners up to this point, and this is where we've been going. And these are partners. So it includes our local municipalities, our state agencies, and the organizations locally. There are probably others out there as well. Bantam Lake Protective Association is also sponsored by a variety of local business owners, and I'm sure that you all frequent them, and I would really appreciate it if you went there right after today's meeting. Patties will be open, so it's right down the road. Litchfield Pizza, it's lunchtime. Litchfield Pizza's right down the road. Whatever floats your boat. But anyways, the point is that these business owners, just like yourselves, recognize the value of this lake and the reason why that it's an important part of our local economy, but also our local community. So they should be acknowledged as well.
I love my town. I love the way they know your name, and they have found how we're together in this game. These planted seeds show such honor for their ground, and when there's need, you'll see the wagons circle round. I love my town. We are raised and we raise our kids, and that circle's rolling.